We are long overdue for a new episode of Your Proofs Are Trash. If you're new to this, I am a PhD math student, nearly done. I expect to be a doctor of mathematics by the spring probably of 26. And this is a little series I started a while ago where the idea was to roast viewer submitted proofs. In the very first episode, I roasted my own proofs. I found the earliest course I still have records of. I have much worse proofs that are just lost to the sands of time that were never teched. So we're going to move ahead. These proofs are probably going to be a little bit better in today's episode than what you saw in the one where I roasted my own. But, it's something. And in order to keep this series alive, though, what I would really like from all of you is for you to submit more proofs to me. So my email's in the description. I want to see your bad proofs. And I do want them to be bad. Too many people, I have a bunch of proofs that people have sent me, but I've never made an episode about them because they're just not that bad. I am thinking maybe I will make an episode on some of them and just talk about, because it's good to see good proofs, right? But, it's better to see some bad ones. So, without further ado, let's get in to roasting my own assignments from... It was from 2019, January 2019. Okay, so this is actually the last year of my undergrad. So, not bad, fairly plain looking. I'm not going to fuss too much about the arithmetic here. I'm not going to check myself on the arithmetic. But this definitely is, I would say, this is okay. Probably... Though this is like too much computation in a paragraph. You know what I mean? Like there's more words and there's more symbols and numbers than there are words here. So probably making more use of display mode equations would be better, to be honest. Like more stuff like this. It just makes it harder to read and harder to follow. So making all of this stuff, if we did this in tech, or why don't I just open a tech file here? You can see some notes of I'm making for an upcoming episode of my categories of modules series. So of course you can see an example of a line mode here, or something like the $$ here. Definitely would have been a better option. I think, for this assignment. There's a lot of assignments, but I think I'm going to be making the same mistakes over and over again. So we'll see how entertaining this is. We might have to dive into maybe some of my other courses in order to get, I don't know, a full video's worth of content here. Yeah, and you can see, so like... You don't always have to do this because, of course, the person who's grading is going to have access to all the questions. But if it's not too much trouble, I'd say it's not a bad idea to repeat the question, especially if it's like this. So the fact that there's a 3D and a 7 here, this indicates to me that probably these questions came from a textbook. So actually, I can open up the question sheet here, and we can see... okay, there was a bunch of questions. I see. There was a bunch of questions, and he said to hand in 3D 712. Yeah, so that's... Maybe it's not the end of the world. It's not a big thing, but, something to consider. Think about it. Your grader is controlling how many marks you get. And, most people are trying to be impartial and judge you based on purely on the mathematical content. I mean, the harder it is for them to understand what you're trying to say, like the worse. Like, this is terrible. I would not do this, just for aesthetic reasons, of course. All in one line like this. Like, this should be in its own separate thing, So Yeah, not the greatest. Not the end of the world, but um yeah. Let's see. We seek to find an integer n such that this is a valid ISBN number. Thus, the following number must be divisible by 11. See, like, this could use more explanation. So let's see. This was 12C. Did I close that file? No, we've got it open here. So let's see what the question was. 12C. This question concerns ISBN code. Oh, I should have said. Did I mention? I mean, clearly it's in the name of the document. But in today's episode, all the assignments we're going over is the 9 assignments I had for my Applied Algebra course. So this was stuff like cryptography and error correcting codes, stuff like that. Okay. Right. Recall that the final digit is a check digit, which can be any one of these digits. Okay, and then I think maybe in the notes it was explained. I'm guessing maybe in the notes somewhere we were told, what the conditions for a check digit are. So it's probably worth repeating it because, for example, me reading it these years later. Now, of course, like the instructor for the course or whoever was grading, could probably see immediately why this is the right thing to check. But there's sort of no explanation as to where this comes from, right? Yeah, there's like no explanation for why that's the case. So that's definitely something that should be there. Is some some extra explanation. 100%. We seek to find an integer. Yeah. So, okay. This is assignment 1. Not the end of the world. I'm guessing this might get repetitive. These other assignments probably have the same sort of comments, right? Like even here, I guess this is better because you can see the sort of ratio of words to, symbols and letters is maybe better, but probably some of this stuff, probably some of these implications. Like I've got this triple implication here. Like this should just be a display mode on its own line. We seek a solution to the system of congruences. Yeah, and like this is probably, I think this is much easier to read if you make it in an align mode environment, right? So something like, so let me type it here. Align x equiv. So I don't even remember what the numbers were, but mod 11 x equiv mod let's say 7 mod 11 and x equiv. I don't like the spacing on equiv or mod either, so I probably wouldn't use those because it makes a weird spacing. But let's put this in here. Right, so something like that, I think, right, that's a lot easier. That's a lot clearer to read. Oh, didn't mean to pop open that window. That's a lot clearer to read, in my opinion. So that definitely could be a lot better. Sure, but let's look through this. Okay, we've got some argument here. So 3 has an inverse being itself. Sure. I don't know if that's worth saying in words, though, right? Oh, and definitely, here's a typo, blank mod 4. What is that? Itself mod 4? Ooh, yeah, this is bad. Okay, this is bad. Don't do this. Don't do this. This is like a mix. This is a big pet peeve I have, actually, when students use it. Like, you're mixing kind of English words and formal terminology here. So the better thing to say would be has an inverse modulo 4. So let me show you actually better things to do. So I'll make a new document, and but you're gonna have to give me a second because I'm just gonna copy paste my preamble so I can do the things I normally like to do. I doubt I'll need it for this, but just in case. So I would write something. So thus 3 has an inverse, namely itself modulo 4. It's still kind of an awkward way to say it. So maybe a better phrasing would be something like, therefore, working modulo 4, we have 3 is, we could say equal, or we could say equiv, 3 inverse. Or, if one wanted, I guess you could say, so you could make the argument that, okay, there's the danger that, of not writing the modulus, because maybe there's several moduli at play here. Like if we're doing some Chinese remainder theorem thing to combine these together. So you could keep the mod 4 in here. But this wouldn't be bad, right? So even though you have some symbols embedded in a sentence, it's like you have a complete mathematical phrase, right? You have a complete mathematical phrase. 3 is congruent to 3 inverse mod 4. So that's an acceptable thing to say, as opposed to like writing mod 4 like this. And no, very bad. Okay. Applying this to final congruence, see. Yeah, and definitely avoid things like this. Now we can substitute this into x equals da 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 da. Well, what do you mean by this? Like, yeah, it's not the end of the world, because I was just talking, I just made some conclusion about what L is equal to, but still, it's a bad practice to say words like this. I think it's much better to just be quite literal, so thus we can substitute. You could, if you wanted to be lazy, you could say something like, thus we can substitute the above expression for L into, whatever the equation was. So don't put the C dots there, put the actual equation, and then, you put it in, and, you get the equation, and it'll look something like this once it compiles, right? So that's right. That would be totally fine. But still, yeah, maybe it's even better if you just reproduce the L, like L equal, I don't know what it was, 3 plus 7x, or, I'm just making up stuff, 3 plus 7m, whatever it was, right? Just be more specific. Or another thing you can do, right? Of course, another thing you could do is you could imagine that, like, we did a bunch of work, and then earlier on, what we could do is actually make this in align mode and get some expression that's like L equals, whatever it's supposed to be, 3 plus 7m, say, right? And then I could go do a slash label here and, call this equation 1, right? And that's even better, right? So then, and then presumably, then we could say something like, thus we can substitute equation ref. By the way, there's also a package clever ref, which may be even better to do. So thus we can substitute this in the equation for x to obtain. And this is even better because now when you click it, okay, it's hard to see. It makes it jump, but it actually brings you to the equation. So again, not a huge deal necessarily when this is just like literally a sentence later. But it's a good habit to get into anyways, and it's better to be precise. So there's many ways you can do it, but the point is just avoid using words like this or that, just be specific. Just write the actual thing that you're trying to talk about. Yeah. Okay, so whatever, that's fine. Okay, so we're doing some cryptography stuff here. From these first congruences, okay, similar sort of things like, yeah, lots of messy calculation. This should be display mode or align mode. Yeah, this is funny. great little secret message for a cryptography course. Okay, so that's assignment 2. Are we gonna go through all 9? I don't know. I might get bored. We'll see. I'll probably yap for another 20 minutes or so. But we'll see if there's anything else interesting. Oh yeah, here I've inserted a figure here. For the first part, see figure 1. Ooh, yeah. So that's bad. I mean, I think there's nothing wrong. I think it's great to, if you include in your assignments pictures to aid understanding. I think that's great. Unless maybe it's an algebraic topology course, your your proof should not depend on pictures. And this is something that would be you could easily tech up. I mean, maybe the carrying of the 2 is, you'd have to think, no, because even then you could just use an exponent or something, right, to talk about the carrying of the 2. So I would not do this. This is easy enough to tech up. Poor form, I would say. Poor form. Yeah, and let's take a look at what these questions even were, because notice there's a lack of sort of preamble or setup. And I mean, again, coming to my own defense, it's more of a computational applied course, but even so, I guess we can close the questions for assignment 1. So what was this? 3E and 4B. 3E and 4B. Even so, yeah, I mean, this is not a hard question to repeat. So for 3E, it's definitely worth talking about, like saying, oh, just start your proof off. Oh, we want to convert 3747 to base 6. Just start with that, just to keep things clear and organized. It's just a much better practice. Same thing with 4B. So just say what you're gonna do. Just say what you're gonna like. It doesn't take a lot of time. It doesn't take much time at all. So, yeah, that's what I have to say to my past self on that. Now, yeah, same thing. Messy computations. This isn't bad. See, this is nicely done, right? I think this is a really nice way to do if you're going to do, if you got to do an assignment and you're doing some row reductions, nice big display mode. You use like an X right arrow here to say specifically what are the row operations you're performing. Makes it nice and clear. So I'd say, that part of it I did a good enough job on. And again, in all of these other questions, they all suffer from the same thing. Same with the previous assignments, right? Like, just give me an introductory sentence here for 7B to tell me what we're doing. Okay. These assignments are pretty short, but I guess there was a lot of them. Now we're getting into some oily boy stuff. Euler's theorem. Yeah. Like here also there could be more there could be more exposition, right? Like that's what I would like to see nowadays is saying something like, suppose, we could even say, recall that if we have a public key, D and E, then, solving. I don't even remember how it goes for this question. A to the D equivalent to whatever, something, right? It's just worth tossing those things in there to give the reader a bit of a signpost of how we're going. Now, it seems like maybe I'm doing a little bit of a better job here. Still no use of a line mode, and why is this on one line with the therefore there? Not great, but I would say this is an improvement from assignments 1 to 3. It's a little more readable. The questions aren't buried, or the computations aren't buried in the midst of a paragraph. Gives it a bit more breathing room. So, all these funny cryptography words, sneaky. This looks good to me. This looks good to me. I mean, so going back, some of this looks a little off. Like having this and the implication here, I would do it. You should do this in align mode so that the 61 squareds line up, so that it would be something like in an align mode environment. Have something like 61 squared plus, and then the other stuff. And then you could do something like I would have right arrow here, 61 squared, and whatever else stuff we had going on. So something like that would be, that would be better. But anywho, this looks even better here. I don't like that this is a comma separated list though. Like these computations should probably be on separate lines, I would say, because this is also hard to read. You want to make life easy for the person that's giving you marks. So I would definitely not make these comma separated lists. I mean, the one pushback you could say is just because there's a lot of computations, and for this all to be in align mode would be, make it very long. And I think I did have to print this stuff out. But I like saving trees. I like trees. But even so, I don't know. It's not the greatest. It's a little chaotic, right? And then there's weird alignment things happening here. One other thing too. So if you see, stuff like this, if you have ORed, definitely you should be typing that. So this is I think it was supposed to be something like the order of some number modulo some other number. So I don't know. Probably this means the order of 5 modulo 16 or something, right? As an element of the group. So you should be using mathrm. Sometimes if I'm lazy and I'm doing something on the fly, I might write it using text. But mathrm is better because, for example, I think if you make it text and this goes inside something like a theorem environment, then sometimes if your theorem environment italicizes words, it will italicize the text, but it won't necessarily do that. Yeah, so see, it got italicized. But now if we look at the mathrm version, then it won't necessarily get italicized in here. So if I compile now, see, so they're both inside the theorem environment, but ORed doesn't get italicized. And you want to avoid that. But also, if you're really lazy, of course, I would go here and define my own command. I would just go /ORed so I don't have to type out mathrm ORed every single time. And now it just looks better. So, pro tips. I guess that's assignment 4. Okay, maybe this will take up a whole episode. There will be more episodes. Don't worry. So, let's see. Assignment 5. Alice and Bob are using Diffie-Hellman key exchange with prime 29. This is nice. This is nice. Okay, so here again, improvement. You can see there's maybe like a little bit of development of myself going on over the course of this semester, right? Between January and February, I got a little bit better. I don't know if this is because feedback on the assignments. I don't have the marked versions anymore, but this is good. I'm using some words to explain things, right? Alice and Bob are using Diffie-Hellman key exchange with prime 29, primitive root, da da da, in order to decrypt, da da da. Yeah. So this is all fine. Ooh, this is, yeah, that's not great. Probably could have found a better way, or even if I hadn't found a better way. So of course, display mode, you're probably sick of me hearing me say that, but also just explaining, like, again, yeah, it's fairly clear from context that I mean that these bars are supposed to be spaces, but again, we want to be building good habits of mathematical communication. So saying somewhere, telling the reader somewhere that those are supposed to mean spaces, yeah. So what else to say here? Okay, and here I'm using align mode more with Lagrange interpolation. Shout out in Lagrange interpolation, by the way. This is so specifically, this is the it's like the key sharing algorithm where basically, so what is it? It's like a degree n polynomial. The coefficients are uniquely determined by if you choose n points that the polynomial passes through. And so the password is like, if you can have a group of people larger than n, but if you larger than n plus 1, but let's say you want to have some sort of secret or password or stash or something that can only be accessed as soon as n plus 1 people agree to it, then you can have each person's own individual key is a point that the polynomial passes through, and then you can only unlock the polynomial using Lagrange interpolation if everyone has that, which is... This is still my favorite. I first learned about it in this course, and I still think it is the coolest thing in the world. Such a brilliant idea. So simple and brilliant. It's just really one of my favorite things. Okay, so here, what are we doing? We're doing some long division. Yeah... Yeah, I don't know how I feel about it. I mean, this is fine. This is fine. There's always a balance in mathematics about how much do you write just in pure technical symbols and how much do you use in the English language. And, probably we used Langle-Wrangle. So I probably, nowadays, I would write this as like modulo the ideal, and then instead of, say, generated by, just put the Langle-Wrangle around this. Depends. Yeah, depends. There's nothing wrong with what I wrote there, I think. Yeah, again, this is weird. Don't ever do this. Don't ever have misaligned equal signs. Also, I feel like it's really awkward. I mean, again, this is a long calculation. It takes up space, but I feel like it's really awkward to split it between horizontal and vertical. Like, once it gets this long, just make it vertical. Just make it vertical. Yeah. So the rest of this looks okay enough. Yeah, things are spaced out more. It's looking better. There's maybe going to be less to say as we move on. Oh, here we go, March 11. What's going on here with this mod 2 squished up? I don't know what's happening there. Yeah, this is looking good. Let's read it. What did I say? If this polynomial is reducible mod 2, then it must have a linear factor. However, we can see it is 1 when evaluated at 0, 1. Yeah, so this is bad. This is bad. This is not good, right? Again, it's just like it's this tough thing about finding the right balance between language, um, when to use English language and when to use math language. And I think I think it would be better if I'd given a name. So um, note that if the polynomial, so I would have given a name like this: f of x equals x squared plus x plus 1 is reducible, then it must factor into linear terms, and thus it must have a root in, what am I doing this in the field with two elements? So I would say something like this. Yeah, then it must have a root in here. And then it must have a root in here. However, and then just do the computation, right? Instead of saying it in English words, like actually show me f of 0 is equal to 0 squared plus 0 plus 0 plus 1 is equal to 1, and f at 1 is equal to 1 squared plus 1 plus 1 is equal to 1. Therefore, blah, 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 blah. Right? This would have been a much better way to do it, I think. Compile. Yeah. So I think this would have been a much, much better way to write things. Okay, so it does not have a linear factor, and so it's not, and so it is irreducible. Yeah. The only other polynomials. Okay, probably maybe this was a question of right, finding all the irreducible polynomials, right? And also though. Right, and this is also not a very good proof, because in the other case, I'm trying to argue that these polynomials are reducible, right? So what does it mean to be reducible? It means that they can be written as a product of other polynomials. So just do that, right? Just do that, like, right? So, therefore, right? Therefore, fx has no linear factors, hence it is irreducible. New paragraph. Meanwhile, and now we can just do an align mode and express each of these polynomials explicitly, right? Express them explicitly as a product. So we could go x squared, little typo there. That would have made things not compile. X squared, oh my gosh. Equals x. Maybe go xc dot x times x. What's the other way to write this? I would even write it so maybe I don't know. Maybe we go this way. So this is equal to x squared. So xc dot x. So we also can do our calculations to show that this is the case, right? X squared plus x squared is equal to x squared plus x plus 1, right? But this is the field with two elements, so 2x would be equal to 0, and I'd have them line up something like this, and then so on and so forth, right? So once we compile, yeah, we see that it looks something like this. Oh, I forgot to make a new line. So the idea is I want to have the other polynomials, yeah, I want to have them lined up. So a little maybe weird to have them right aligned, but this way it allows us to do the computations and reach the final conclusion, right? So I probably would have done something like that. Yeah. Therefore, each of these polynomials has linear factor and thus and is thus reducible. So this is the only irreducible polynomial of degree 3. Yeah. Okay. Probably similar things going on in the other case. Yeah, not so bad. Let's see, we're almost through this. Assignment 7. Yeah, still kind of weird. I didn't just make this display mode, but whatever. This all looks fairly normal stuff. Yeah, the possibilities for... Yeah, like this, I don't know. And what do I mean by this, right? So new code words are given by solutions to the, again, if you got something this big, it should be in display mode. It should be in its own thing. Or rather, the system of equations, the possibilities for the first 3 bits satisfying the first equation are this. Yeah, I guess it's okay to list them. But you know what? I would maybe add in a little bit more of an explanation, right? I would say something like, so, yeah, why am I even saying it like this? Like, this is, yeah, this is a system of equations. So this is such a silly answer. What I should have done here is just fully reduce this, reduced row echelon form. It couldn't this be? This could be reduced more, right? So what I should have done is first reduce this equation more, and then what I would have had. Let me just write it out, I guess. What I would have had is like 2 equations. Or even as is, right? Two equations, in 4 variables, and I could have said, well, let, x3 be equal to, let s be in what, the field with 3 elements. Let x be s3, x3 be s, sorry, and then solved for x1 and x2, right? Like the more rigorous way to do this would have been to put it in reduced row echelon form and then argued about how many free parameters there are. And then that would have been a better justification for why these are the only bits. I mean, yeah, again, not the end of the world because you can see it by inspection, but like, how do we know that this list is exhaustive? Like, it's just so much more rigorous and precise if I'd done it that way. But sure, okay. Yeah, again, this min shouldn't be italicized. One may easily verify by inspection of the above that this, yeah, again, that's bad. So I don't even know what D is supposed to be, the diameter of the code or something. But come on, that's just lazy. One may easily verify by inspection. Just take the definition and just compute it. I hope I lost marks for that. Yeah. Okay, final assignment of the video, assignment 9. Let's see, any VK Lambda design. Yeah, again, okay, I'll shut up about align mode, but I haven't had this specific critique about it, though. If you've got fractions like this that are popping up again, yeah, those should be in align mode or something. This is also bad, right? We find that the squares in Z19 may be given by squaring the first half of its elements. Like, it's true, right? It's true because, like, I squared will be equal to minus I. right? But put some of that explanation in, and yeah, these words like first half of its element. What are the first half of Z19, Z mod 19? I mean, I know I know you know what I was talking about, and the marker probably knew what I was talking about. But again, it's just like, yeah, math is only going to get harder from here. If if you watch it this far, you must really be interested in math and in writing good papers and research level stuff, right? Not to say that I don't have my own sloppiness in my recent papers or anything, but like, you want to mitigate that, right? So you want to get out of these sloppy, vague habits earlier. Hopefully, I've grown out of these somewhat, but yeah, I don't know. I don't know. This looks okay though. Unless these points are on the line. Do do do. The rest of this looks alright. Well, that's it. So I think that's gonna do it for this episode. So that is what my proofwriting abilities look like in the winter of 2019 in the context of applied algebra. If you want to see more of these videos, then I would encourage you to participate in these videos. Send me your terrible proofs. I can make your name anonymous if you like. So that way, yeah, you're not getting doxxed or something for showing your bad proofs. But, I also plan to dig into more of my bad proofs. And we may even see some proofs of mine that are not so bad once we run out of the worst ones. So, thanks for joining me, and QED.